Cramer rule, that is in order to find out the variable, three linear equations, that is you have three lines. Now three lines can intersect, three line can be same, or three line can be in different plane. So you have different way of comprehending. So this is our first linear equation, a1x plus b1y plus c1z equals d1. There are other lines also. So there are three lines actually here. Now all a1 till d1, they are constant, x y z are variable. So we need to find out x y z. In the two system of two linear equation, it was just x and y. Here we have x, y and z. X will be d1 by d, y will be d2 by d, and z will be d3 by d. And what is determinant? What is d here? Whatever is in the left hand side, all the coefficient you have to write. That is a simple way of writing it. So this is the whole matrix, or you can say the determinant of this matrix, that will be D. So I am writing D, and I'll tell you how to write D1, D2, D3. So I am writing A1, A2, A3, B1, B2, B3, and C1, C2, C3. This is what? This is your actual determinant D. D. Now, in order to find out D1, just replace the first column by the right hand side. That is D1, D2, D3 has to be placed in A1, A2, A3. So D1, D2, D3, you have B1, B2, B3, and you have C1, C2, C3. This is your D1. Same way, we can also find out D2. What is D2? The second column has to be replaced by, because we are targeting Y here. Just replace B1, B2, B3 by D1, D2, D3. Other things remains the same. For example, A1, A2, A3 will remain there. C1, C2, C3 will remain there. Only the middle one, which is B1, B2, B3, has to be replaced by D1 till D3. Now, same thing we have to do for D3 also. That is, in D, we are targeting now the Z. D3 will be used for Z. So A1, A2, A3, B1, B2, B3 remains same here. But the third column has to be replaced by D1, D2, D3. I hope you got the idea. So this is x, d1 by d, y will be d2 by d, and z will be d3 by d. So this is how all values can be computed. But there can be various scenarios. What can be the scenarios? If the determinant is not equal to 0. Because if three lines are intersecting, that means if d is not equal to 0, you will get some proper solution, or three intersection or three lines intersecting at a common point, and that point will be the actual solution, and that is going to give you a point in 3D plane. X is d1 by d, y is d2 by d, and z is d3 by d. So you'll get a consistent and a unique solution. What about when all of them are 0? D also 0, d1, d2, d3 also 0. So that means all these three lines are same. So when the lines are same, that means they are not intersecting. Actually, they are intersecting in infinitely many points, because all the three lines are same. For example, x plus y plus z equals 3, and so 2x plus 2y plus 2z equals 6. They both are same. And third condition, if we have multiple conditions inside this also, if the determinant is 0 and one of these d1, d2, d3 is not equal to 0, then the system is inconsistent and it has no solution. Okay, one of this is not equal to 0, because d is 0, that means in the below part, or the denominator part is 0, that is it will make it inconsistent. If d1, d2, d3 is equal to 0, then we call them as a homogeneous linear equation. If the determinant d1, d2, d3 is equal to 0, then this is homogeneous linear equation. In this case, if d1, d2, d3 is 0 and determinant d is not equal to 0, then the system has very simple and trivial solution, that is all x and y and z are, and all those three are 0. Because d is not equal to 0, but d1, d2, d3 is 0. Okay. So d1, d2, d3, if they all are 0 and the determinant is not 0, we have a traditional trivial solution, x, y, z equals 0. But if d1, d2, d3 equals 0 and d is equal to 0, we have already seen in the second part, the second point you see, it will have infinite Meillet solution, because all the three lines are same. Let us take an example of this three linear equation. So we'll use the Cramer rule. We have these three equation, and these three are equation of line in 3D plane. So let me tell you, first thing you have to write is d, and d will be all the values on the left hand side, right, in the form of matrix or determinant form. So 5 to 5, coefficient of x, negative 1 3 negative 2, coefficient of y, 4 5 6, coefficient of z. Okay, d you found. I hope you'll be able to find out the determinant of this value. We have already done discussing this. So say it is 51, not equal to 0. Now in place of 5 to 5, replace it with whatever is on the right hand side, 5 to negative 1. So 5 to minus 1 we are writing here. Other things remain same in the d. You'll get a determinant which we call as d1. d2 is what? The middle one, because we are targeting y here. So this one, minus 1 3 negative 2, has to be replaced by 5 to negative 1, and again the determinant has to be found out. So what do you get here? 102, so say. Now d3 is the 4 5 6 has to be replaced by 5 to negative 1. Okay, one by one, you replace first column, second column, and third column by 5 to negative 1, and this is how you get d1, d2, d3. So let us say it comes as minus 102. And what is the x is d1 by d, y is d2 by d, and z is d3 by d. Okay, so this is by Cramer rule. You get x as 3, y as 2, and z as negative 2. Please remember, d is not equal to 0, then we found the solution. Otherwise, other options will come, other scenarios will come. Okay, this is all about this discussion. Thank you so much. Take care of yourself.